Okay, hello, and welcome to this second preview presentation for Impact. The reason it's a second preview presentation is because we're tuning the perspective and the terminology used in Impact so that the developers who would benefit from this would actually understand how they benefit from this, and also being able to reach as many developers as possible that could benefit from this. So that is why Impact is now has a tagline of reactive contexts for React. And Impact is born out of this experience of building complex productivity types of applications where the main challenge isn't what React is currently diving into with like data fetching on the server integrated with components and rehydration on the client and all of this to kind of show things as fast as possible. It's more that when the actual app runs on the client, you want it to be super performant and snappy. And there's a lot of client state management you need to handle because of all the interactivity in the application itself. So the first thing we're going to talk about to understand reactive contexts is reconciliation versus observation. So when you create a React component, you can define that component as a function. And when that function is called, it can be passed props. And by looking at those props, you can dynamically decide what UI you want to show for that component. And whenever those props update, the function is called again, and you can return a different UI. And React will magically optimally update the actual DOM. And this is called reconciliation. And what makes React unique here is that you just use JavaScript. There's no special templating language. It supports TypeScript 100% because it is just a language. And I think this is why we kind of stick with React primarily. Even though this was kind of the first feature of React, and there's like server-side components and suspense and all of this stuff now, this is why we stay with React. A challenge occurred though when these function components, they needed some state management. And the only way to really get state management into these components running or these functions running within the reconciler was to introduce these hooks. And that was a good way to do it. Like, how would you do it differently? But the problem is that it adds a layer of complexity. When you just evaluate what UI you want to show, that's a very obvious, simple thing to think about. You have a component, it takes some state. Based on that state, what UI should I show? But when you do state management, you suddenly have these new primitives of useRef, useState with a callback, you have memo, you have useEffect, and they have dependency arrays. And this function will be called again and again, not only to produce UI, but to also evaluate these props coming in, its internal state. And it just gets, this is where the friction occurs. This is why people have a hard time with React. And the UI is why people love React, in my opinion. But when it comes to observation, it kind of flips around, because with observation, you only call the function component once, and you have to bind the state dependencies coming from the props to these primitives that will create the dynamic behavior of the UI. It being like a match or a for or whatever. This is just pseudocode. It needs to do that. And that means that this just doesn't work with the language. It has challenges with TypeScript, and you need to learn these primitives and how they work. And some solutions have their own templating languages that needs to build their own type checker to be able to make that thing work. The beautiful thing about observation, though, is that in a reactive paradigm, there is no reconciler. There is no special runtime for state management. It's just the runtime of the language. So you decide how you want to organize and write this code. The only thing that's like unique about it is that it's not just values, right? the state values, they need to be wrapped in a reactive primitive. And there are different solutions for this. Impact has its own signals implementation. You also have MobX, Preact, and Legend. And these are just different, like they're different implementations, but they fundamentally do the same. But they have different flavors and like signatures. And I can immediately say that Impact supports all of these. And we're going to look into more of that. But the conclusion of this is that what I think is a good way to build UIs is that you observe state and you reconcile UI. But that's not all of it, because we also need to organize our state management. And what typically happens when we do state management is that we start with React, and we use the state management primitives of React, and we pass props to share state with other components. And then we get into performance issues, or it's just a hassle to pass stuff down so much. And we use contexts. But then we build up the context, they get too big, and those become a performance issue because it's an all or nothing deal with the context. It doesn't matter what state you change inside the context. The context value itself will change, and any consuming component, regardless of what state they're actually using, will reconcile. And then you start splitting up the contexts and try to handle it that way. But then it's difficult, like if you depend on this and this depends on this, and it just becomes unnatural because you don't split it up for organizing it, you split it up for performance reasons. And then we kind of, oh no, I can't deal with this. Let's just go global and use some reactive primitives instead. So global, you see it there. And this definitely solves all this friction. Like suddenly you're free from the reconciler. You can do your state management with reactive primitives without the runtime of the reconciler. But we actually leave something behind with contexts. And we also get a problem. And the problem of doing global state management is state dependency. So this is the simplest way I could explain this concept, because it's not that easy to kind of visualize it because it's about complexity. But hopefully this makes sense. So if you do a global state management, you might have a user and you have a dashboard. And that dashboard has some posts that that user can see. Now, in a global context, you need that user, but it might not be there, right? And not only that, you need to asynchronously get that user. And you should only display the dashboard and load the posts if you actually have the user. So now first of all, we had to define like a non-user, but we're also defining, we can't see the state dependencies, right? And what can happen here in the worst case is that maybe there's one user and you fetch some posts for that user, and then you change the user, but you forget to reset the post, for example. So there's no clear dependency between state and the management of that state. So what Impact does to resolve this is that it allows you to keep these amazing reactive primitives you do for global state management, or you get access to in global state management, but allows you to use them in React contexts so that you have a clear hierarchy of state dependencies. So as an example here, we can see how Impact does this. And I'm going to use the Impact signals implementation for the reactive primitives, but you can use MobX, you can use Preact, you can use Legend if you rather want to do that. Impact is only about the reactive context. So if you imagine here, we have an App Store provider that's mounted in the component tree, and it receives a session with a user. And we key that App Store provider on the ID of that user, which means that if the user changes, the App Store provider is remounted, which means that it cleans out all the state management related to that specific user. And of course, it also passes in the user itself. Now, in this App Store, we have the App Store is defined as a function, and this is the reactive context. A reactive context is defined just with a function, and it will receive props just like you would do with normal React context. Now, the difference with these props is that they are actually observable. So when we use these props and access them, we access them as observable props, which means that if the user would be updated here, that observable property of user would actually trigger observation to whoever is observing props.user. Another aspect we can see here is that within this store, you're able to use parent reactive context. So we have another reactive context here called global store, and we're able to use that inside this nested store. And we're accessing the API from it. Then we use one of the reactive primitives from Impact to create a query. And that query is to get the notifications for that user. And we get the query itself, and we also have the ability to invalidate that query, which is a pattern we know from React Query and SWR, which are solutions you can still use with Impact if you want to do that, or you just want to do like traditional global promise your own loading states and all that stuff. But what we can see further is that there's a cleanup primitive here. So that means that when the App Store provider unmounts, this cleanup will actually run. It takes a callback and it will run that callback when the App Store provider unmounts. So what we do is that we subscribe to user notifications, and whenever there's an update, we invalidate the notifications query, and it will go and fetch the notifications again. And that returns a disposer for the description, so that when the App Store provider unmounts, it will unsubscribe to that subscription. Finally, we can see that we are returning a public interface from this store that's accessible by any nested component and nested reactive context. And what we do is that we just create a function called user where we return props.user. And the reason we do this is because Impact Signals is based on a pattern where you call the value as a function to like unwrap it and do observation. So notifications query here is an actual function that you need to call to unwrap the actual notifications query. Now, in an actual component that's nested in this App Store provider, we can see that we can now just use the App Store, and we grab the user here. And there are different ways to do observation in components. I just wanted to showcase a very specific way of doing it, where we ensure that the only thing that reconciles here in this component is when the user changes. So we have an observer that returns the username, and you can see we call the user to unwrap the actual user value, and that causes that specific point in the component tree to update whenever the user updates. And then we mount a notifications component. In this notifications component, we use a general component observation approach that Impact Signals has, which is called use observer. But here you would use, if you use MobX or Legend or Preact, you would use their observers. Regardless, we go and grab the notifications query from the App Store. We unwrap it to the current notifications query, and we are able to now look at the status of this promise of grabbing the notifications to show a loading state. We can show an error state by looking at the reason of the promise. And finally, we get the actual value from the promise, which is the notifications, and we display the UI. And this shows you how now with React really embracing suspense and getting the use hook, there's new observability possibilities. So impact signals has first-class support for promises, which means that you can actually look at promises in your components on their status to render UI, or you could send the promise to a use hook and it will use suspense. So that was just a showcase of how you would use a reactive context specifically with impact signals. But as I said, you can use reactive contexts with MobX, with Preact, with Legend, really with any reactive primitive. But as you will see on the website, you have some packages to get going more easily with the before mentioned solutions. So with all this experience of trying to use React for state management, doing global state management, there is this like underlying brewing things that you don't quite understand when you experience friction. And getting to this point of understanding that going global, you actually lose something. And what you lose is the dependency between states. So there's certain state management you can do at a global level, but you need to resolve that state and then pass that to some nested state management, because you need to show a UI for loading states or whatever it is. And then you do state management for maybe a specific page. But then there's certain state that needs to be resolved on that page to be able to show a specific feature. And again, you use React and you show UI and you resolve that state dependency in React. But then you pass it to a store that handles the complexity of the state management of that specific feature. And this is the key of what the impact solves. And we wanted to make that available to as many people as possible, as already embracing reactive primitives for state management, and if they feel the same friction. So yeah, that's it. Thanks.